Hello students, good morning. You all are safe, right? Okay. Now in the last class we are discussing about electricity, the chapter electricity, and we are discussing the topic called potential difference. I hope you got the concept of potential difference. And just a summary of our last two classes. We started with electric charge, isn't it? So electric charge is represented by the letter Q. Then electric charge, the unit of electric charge is coulomb. It is a scalar quantity. Then we move to what? Electric current. I am just saying the important points only. Then electric current. Electric current is actually the rate of flow of electric charge. It is represented as I. So I is equal to Q by T. Okay. Then the unit of electric current is ampere. So 1 ampere is also equal to 1 coulomb by 1 second. Okay. Now we studied about a device which is used to measure the electric current. It is called what? Ammeter. Ammeter is the device used to measure electric current. It is always connected in series in an electric circuit. Then we discussed about electric circuit. Electric circuit is a closed and continuous path through which electric current flows. The switch will act as the connecting link between different components. The minimum requirements for an electric circuit are, what are they? Let's tell me. First one is electric bulb. Second is switch, and then what? A cell or a battery. Then we distinguish between cell and a battery. Cell contains only a positive and negative terminal, whereas battery is a group of cells which contain large number of positive and negative terminals. Okay. Then we mentioned the direction of electric current, both electronic current and conventional current. Electronic current means flowing from negative. The electron, movement of electrons is considered as electronic current, and it is always from negative to positive. Whereas conventionally the direction of electric current is taken from positive terminal of the battery to negative terminal of the battery. This much is clear about electric current. Then there are two circuits like open circuit and closed circuit. When the switch is closed, the current will flow through the circuit. It can be considered as a closed one. Whereas open circuit means as the key is open there. So there is a break in the circuit. So there will be no flow of electric current. Then we move to the different symbols. We studied the symbols for cell, then battery, then switch, bulb, okay, ammeter. Then we move to potential difference. So it is very important. Potential difference, also we call it as voltage. Potential difference is represented by the letter V. It is actually the work done to move a charge from one point to another. So V is given as W by Q. Okay. Then the volt is also represented as joule per coulomb, as 1 volt is equal to 1 joule by 1 coulomb. This much we talked about potential difference. Then the device used to measure potential difference is voltmeter, which is always connected in parallel in a circuit. Then we told that the device which is used to maintain potential difference, the device is cell or a battery. Okay, please keep in mind that word is very important. Maintain potential difference, or the source of potential difference is, who is that? It is cell or a battery. So this much things we explained in the last two classes. Now today we are moving to the most important law, one of the most important law in physics. And the name of the law is very beautiful. It is Ohm's law. What is that? Ohm's law. Okay. So shall we move to that? Okay. So this Ohm's law is actually giving a relationship between the current and the potential difference. Understand? We studied two main physical quantities in this chapter. They are electric current and potential difference. So this Ohm's law gives a relationship between, what are they? The potential difference V and the electric current I. Okay. Actually, this was discovered, or the Ohm's law was stated by a scientist named George Simon Ohm. Okay, George Simon Ohm in 1827. So George Simon Ohm want to find a relation between what potential difference. He searched whether there is any connection between this V and I. So for that he demonstrated one experiment and then he could find a relation between V and I. Okay, so in your textbook there is an activity given there and that is the activity that I drawn here with the figure. So with this activity you will understand what is the relation between V and I, and also after that we can state the law. Statement of law is very important. So before moving to the statement we will first discuss the activity and then we will reach out to the law. Okay, so listen here, this is the circuit used to study the relationship between voltage and current. So what are the things used here? Here there are some cells, right? Some cells are connected here. Then he used a voltmeter to measure the voltage or potential difference. Ammeter to measure the, what is that? Current, electric current in the circuit. Then we have a switch and also the connecting wires. Here you can find something different, something peculiar thing that you haven't studied in the last class. What is that? It is this one. Okay. What is this XY? Here we have to consider a conductor, right? That means a material which conducts electric current or which allows electric charge to pass through it. So in the last class we used a bulb. You know that electric bulb contains a filament. What is that filament called? It is tungsten. So tungsten has some special properties, so that we are using bulb there. Similarly, in the laboratories we are using a wire which always we use that particular wire for doing experiments, and it is used as a very good conductor there. Actually it is not a conductor because it is an alloy. Okay, that particular material is a alloy and it is made from nickel, chromium, manganese, iron, etc. Okay, can you guess what is that material? As it is nichrome. Okay, nichrome is the alloy we are using in the laboratory for doing such type of experiments. So here also I am taking a small piece of nichrome wire here. Nichrome wire is connected here, that is this XY. Now this symbol I will discuss later. Understand? So what are the things I have taken here? They are the cells or the battery, then ammeter, voltmeter, key and a nichrome wire. Understand? So instead of bulb, we can use a nichrome. Now I already told that nichrome is an alloy. So alloys have some special properties. Individually, if I am taking a particular metal, means it will the conductivity of an alloy will be more than the conductivity of each metals. Understand? The metals present in it has a certain amount of conducting power. But if I am taking an alloy as a whole, means it has more conducting capacity than the individual metals present in it. So that is why nichrome is used here, and it has some other properties also. It will not get oxidized at room temperatures. It will not get heat. It has large high melting point. So such properties are there that we will discuss later. Anyway, here we are using a nichrome wire which is an alloy. It conducts very nicely. Understand? So here what we are doing is, first we will use only one cell. So first we are using only one cell and then we will check, we will switch on. Okay, then the circuit become closed. Then the current starts to flow. The direction of current is given here from positive of the cell to negative of the cell. So here this current starts to flow. At that time we can measure the current through the ammeter. Understand? And also the potential difference we can measure through the voltmeter. So first we have to write how many cells we used. So first we used only one cell, isn't it? Only one cell we used. Then we measured what? The current and the voltage flowing through this circuit. For example, let the current be let the voltage be 4 volt. Let the voltage be 4 volt. This is just an example only, and at that time I got the current as 2 ampere. Understand? 4 volt and current is 2 ampere. Again I used one more cell. That means now I have 2 cells. Okay, 2 cells I used. At that time I will write the number of cells used is 2 and the voltage I measured is 6 volt. Clear? And I got current as 3 ampere. Okay. Now again I increased the number of cells. The number of cells I increased. So again let it be, the current be 4 ampere and the voltage be 8 volt. Okay, this way I got the measurement. You assume like that. Now we found the ratio because we are checking whether there is any relationship between voltage and current, right? So here we are measuring this V and I using a voltmeter and ammeter, and then we are taking the ratio of V and I. So for each case, if you are taking the ratio, what will you get? 4 divided by 2 will give you 2. Again 6 by 3 will give you 2. 8 by 4 will give you 2. So it is seen that this V by I remains a constant. Understand? This V by I remains a constant throughout. Okay. So if V by I is a constant, V by I is a constant means that V is proportional to what? I. V is proportional to I. So what does this mean? This means that whenever the potential difference increases, the current also increases. If the potential difference decrease, the current decrease. So there is a direct relationship, direct proportional relationship between voltage and current. You understand? So that is the relationship that he could find from the activities or the experiments. With that, he stated the law. Okay. So this activity, you understand? We considered a circuit like this. Then we connected different cells. We increased the number of cells in each turn. Understand? By increasing, we could measure the voltage using a voltmeter. Here you can see that the voltmeter is connected in parallel with the wire. Okay, in the last class we used a bulb and we connected a voltmeter in parallel. Ammeter is always connected in series. Then we told that the negative of the voltmeter should be connected to positive of the ammeter. So connection should be very precise, okay, very much accurate. Okay, now we measured V and I, then we took the ratio for V and I, we got a constant value. Understand? From that, he could conclude that this V is proportional to I. If V by I is a constant, V is proportional to I. Then he moved to the statement. Okay, so next we are going to study the statement, Ohm's law. How to state Ohm's law. So let us move to that. So please listen to the statement of Ohm's law. That is, the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. Okay, once more. The potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. So this statement is clear because in the last activity we have seen that we took a metallic wire like nichrome, then we found the relationship between V and I, that is potential difference and electric current. Then we have seen that this V and I are directly proportional, isn't it? So here it is said that if you are taking a metallic wire and it is connected in an electric circuit, we can measure the potential difference V, and it is found that this V across the ends of the given metallic wire is directly proportional to the current flowing through it. Understand? To the current flowing through it. And what is the condition? It is very important. The temperature should remain the same. That means if you are conducting the activity in the lab, For example, we have to take a fixed temperature. Suppose if it is 34 degrees Celsius, in that temperature we have to do the whole experiment. Understand? So that is the only condition here. The temperature should remain same for throughout the experiment. Then we will get a relationship like V is directly proportional to the current I. So once again the statement, the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it provided its temperature remains the same. So now itself you have to by heart it. Just understand the concept and then study. Okay. Okay, the statement is clear. Now we will go for the mathematical expression. Okay, so with this statement we can write like this. V by I is a constant, isn't it? V by I is a constant. So we can write V proportional to I. V proportional to I. Now in maths you have studied that if you want to change this proportionality constant, we will multiply with a constant value, isn't it? This proportionality sign can be changed by multiplying with a constant value. So here we can multiply with a constant called R. Okay, so this R is the constant of proportionality here, and this R is one of the physical quantity in physics which we call it as resistance. Understand? So R is the constant here and it is the resistance of the conductor. Now we have to discuss this resistance in detail. So the word itself, it is clear. Resistance means what? To resist the flow of current. In an electric circuit, this resistance, the property of resistance is to resist. Resist means what? Tadaiga, alle? Resistance is the property to resist the flow of electric current. Understand? So here every conductor, every metallic wire, every wire, every material has this resistance. But how will it change? You have studied two types of materials like conductors and insulators. Conductors and insulators. Okay. So as I told, every material have this property called resistance. Okay. Now when I consider these conductors, you know that conductors are the materials which allow electric current to pass through them. If they are allowing electric current to pass through them, we can understand that the resistance of conductors is very less. Understand? That means every material has a property called resistance, and in conductors easily allow the passage of current. So if the current is flowing fastly or if there is no problem, the current will flow, right? So in such materials, the resistance is very low. That is why the current is flowing easily. Understand? But for insulators are poor conductors. They are not able to allow the passage of current. That means it has high resistance. Okay, that insulators are the materials having huge amount of resistance or high resistance. Okay, you got it? So resistance is the property of every material, and what is the property there? To resist the flow of current. Okay, and this resistance will change depending upon the materials. For a conductor, the resistance is very, very low. But for insulators, the resistance is very large. You got it? Now, we want to study the unit of resistance. The unit of resistance is ohm. What is that? Ohm. Unit of resistance is ohm. Okay. So in our activity we have seen that V by I, we got a constant value, right? V by I, we got a constant value, and that constant is called the resistance. So if V by I is a constant value called resistance, and if you are plotting a graph between V and I, if you are plotting a graph between V and I, what is the shape of the graph? You have studied that. If two quantities are directly proportional, what is the shape of the graph? So let us plot a graph like this. So this is V and this is I. Clear? Now, let us plot the values that we have took there. That is, we took the values like 4, then 6, 8. Okay. Here we took the values 2, 3, then 4, 5, etc. So for current is equal to 2, I have voltage as 4, right? So I will plot like this. Again, here I will get here, then it's not the actual measurement, I just plotted. So okay, now by joining the dots, joining the points, I will get a straight line like this. Let us assume it has a straight line, okay? Okay, so this is the straight line we are getting when we are plotting a graph between V and I. Okay, so here from this particular graph also I can calculate what? Resistance. How can I calculate? By taking the y distance and x distance. In the y axis I am putting the value for V, and in the x axis I am taking the value for I. So if I take a particular value like this value I am taking, okay, this value. So you know that here it is 6 and here it is 8. So what is this value? This is 2, isn't it? 8 minus 6. So this value is 2. Again, if I am taking this particular value, 4 and 3. So what is the difference? It is 1. So I can say V is equal to 2 and I is equal to 1, which you will get it as 2 ohm. 2 ohm. Now you look here. This is the symbol used to represent the unit ohm. So we write it as ohm, but we use the symbol like this. So this is the symbol used to represent what? Ohm. And ohm is the SI unit of resistance. Ohm is the SI unit of resistance. Understand? So from this graph it is clear that the VI graph is always a straight line. One more question only. Okay. And from the VI graph we will calculate what? Resistance. How we will calculate resistance? By taking the y distance and x distance. Y distance is V and x distance is I. So V by I will give you the resistance R. The unit of resistance is ohm. Okay. And how will you define resistance? It is the property of a conductor to resist the flow of electric current. To resist the flow of what? Electric current. This is clear? Okay. Now the resistance is very less for conductors and the resistance is very much large in the case of insulators. Clear? This much is clear. So again, this graph is always a straight line. We get the physical quantity resistance from the VI graph. Okay. So this is all about resistance. Now we will look into the details of resistance. Okay. So resistance, now you got it. Then the unit of resistance also you understood. So I will write here resistance is the property of a conductor or a material, okay, to resist the flow of electric current. Clear? Now the unit of resistance is SI unit is ohm, represented like this. This is the SI unit of resistance. Then it is denoted by this equation. V by I is equal to R. V by I is equal to R. Clear? Now look here. When I increases, the resistance of that particular circuit will be low. I told that. Okay. In conductors, the current is more. It can easily pass the current. so that the resistance is low. So always this I and R are inversely proportional. I and R are inversely proportional. That is when I increases, R decreases. I decreases, R increases. Okay. So that is the relation between I and R. From this it is clear, no? But in some circuits, there will be need of something, some sort of component to increase as well as to decrease the current. Okay, when we connect an electric circuit by using different components and while doing the experiments, it is necessary to change the current in that circuit. For example, if I want to move from 2 ampere to 4 ampere, there should be some device. And that device should be in such a way that it should not disturb our main voltage source in the circuit. Understand? That means in an electric circuit, when we are doing experiments, there will be chances like if you want to increase the current from 2 ampere to 3 ampere, 3 ampere to 4 ampere. In such cases, we have to use a particular device, isn't it, for regulating the current. But when we use such a device, the device should not disturb the voltage source that we are using. We will be using a battery in that circuit which will maintain the potential difference. So when we use such a device, this device should not disturb the voltage source. Without disturbing or without changing the voltage source, it should change the current. It should regulate the flow of current. It can increase or decrease the flow of current. So such a device used in the electric circuit to increase or decrease the electric current without changing the voltage source is known as rheostat. What is that? Rheostat. So what is the use of this rheostat? It is used in an electric circuit for what? For regulating the flow of electric current. Means to increase or decrease the flow of electric current without changing the voltage source. That means we will be using a battery in the circuit to maintain the potential difference. We are using rheostat also in that circuit. So this rheostat should not change what? The main battery. Understand? That is what meant there. So rheostat is the device which is used to regulate. Okay, regulate the flow of current in a circuit. Regulate the flow of current in a circuit without changing. Okay, without changing the voltage source. Okay, it's very important. Without changing the voltage source. This is called a rheostat. So rheostat can be varied, right? It can be varied. It has different values of what? Resistance. So rheostat is also known as variable resistance. Rheostat is also known as variable resistance. That means it can vary its resistance. When we are varying the resistance, the current increases or decreases, isn't it? That because there is a relationship between current and resistance. So when we increase the resistance, the current flowing will be low in the circuit. When we decrease the resistance, the current flow will be higher in the circuit. You understand that? For that purpose, we are using a rheostat. Clear? So rheostat is the device which is used to regulate the flow of current in a circuit without disturbing or without changing the voltage source. So rheostat is also known as variable resistance. Okay. Now we will move to the symbol of rheostat. Okay. Okay. The symbol used to represent rheostat is like this. Okay, or this is also used, which means that the resistance can be varied. Now you have seen this thing in our first circuit, in the first activity that we have mentioned in the class. Now I will say that this is the symbol for resistance. Okay, the symbol for resistance is this one. Now, if I draw a line like this, it indicates that the resistance can be varied or changed. Okay. So variable resistance is called what? Rheostat. So this is the symbol for rheostat. This is also used. This is commonly used in the electric circuits. We are drawing this thing. So this is a symbol used for variable resistance or known as what? Rheostat. Understand? So this is about rheostat and its symbol. Then resistance symbol is this one. Okay, now you understood why I put that resistance, symbol of resistance in the nichrome wire. Because we are taking a wire which is able to conduct, and this wire has a particular amount of resistance. And when we take the measurement for V and I, and when we took the ratio of V by I or V and I, we got a constant value. That value is actually what? The resistance of the nichrome wire. Understand? So we calculated the resistance of nichrome wire there. Okay, so R is equal to V by I. Now we can discuss more about the unit. Okay, I said that the SI unit of resistance is ohm, isn't it? The resistance has its unit as ohm, and it has an equation like R is equal to V by I. R is equal to V by I. So I can say that the resistance becomes 1 ohm when the potential difference is 1 volt and current is 1 ampere. Isn't it? So if there is a question like define 1 ohm, how will you write? If there is a potential difference of 1 volt in a metallic wire or in an electric circuit and it carries a current of 1 ampere, then we can say that it has a resistance of 1 ohm. Understand? So this is about the definition of 1 ohm or the unit of resistance. So I can write 1 ohm as also equal to 1 volt per ampere. Volt per ampere. So don't get confused with the units. We have studied so many units up till now. So you have to go through it. Okay. So volt per ampere is also called ohm because V by I is equal to R. Okay, so we studied resistance, the unit of resistance, then variable resistance or another name as rheostat. Then we studied about the symbols of resistance and variable resistance. Now we are studying another one more term, that is resistor. Okay, resistor. You may have seen resistors. Resistor. So resistor means it is also material having a fixed value of resistance. This resistor is a small thing. Actually, it is made up of carbon, and it is all in every type of electrical appliances. You can see when you open for TV, then any electrical appliance when you open, you can see there resistors, capacitors, so many components are there. So resistor is actually a small carbon made material, and it has a fixed value. We told that in rheostat we can vary the resistance, right? While we are doing experiments in the laboratory, we are using rheostat, and also resistors we are using, but resistors are having fixed value because a resistor will look like, it's a small thing only, like this. It consists of some colored rings there, and these colored rings has certain values. Okay, with that value you study in 12th standard. So with that value we can identify what is the value of that resistor. For example, it will be 5 kilo ohm or 5.6 kilo ohm. Okay, then 220 ohm. Like this, it has a fixed value. So there may be cases where we have to use a fixed values of resistors in electrical appliances. So such type of resistors are also there. These resistors are having fixed value for their resistance. It cannot be changed. It is already made like that. Okay. It is having colored rings there. Each color has a value, and that is that value, that total value. How you calculate that, all you study in your higher classes. So it has a value, and that is the fixed resistance of that particular resistor. But we are using rheostat to vary the resistance. We are using a variable resistance to change the flow of current in a circuit. Understand? So this is all about resistance. Okay. Now we'll just summarize these points. So firstly we studied Ohm's law and the statement. Okay, don't forget the statement. Understand the concept and study. Then it will be easy for you. What is the statement? The potential difference across the ends of a metallic wire is directly proportional to the electric current flowing through it, provided, what is the condition? The temperature should remain the same. And from that we got the equation, that is V by I is equal to R. V by I equal to R. R is the resistance, which is the opposition or to resist the flow of what electric current in a circuit. This resistance will vary for different materials. It will be less for some materials and will be large for some materials. So depending on that we can understand whether that material is conducting or not. Okay. Now the unit is ohm, represented like this, and 1 ohm is equal to 1 volt by 1 ampere. Now there are variable resistance or rheostat used in a circuit which will regulate the flow of electric current without changing the voltage source. Then we are using resistor, which is having a fixed value for resistance. Resistors are also used in electrical appliances which is having a fixed value. Each resistor is having a fixed value. Then we have studied about the graph, VI graph. The VI graph will give you resistance by taking V by I from the graph, and this shape of the graph is always a straight line. Okay, the shape of the VI graph is always a straight line, which indicates that V is proportional to I and V by I is a constant. The constant is called the resistance. Clear? Now finally we are going to study the electric circuit used for doing Ohm's law experiment. Okay, we have to do the Ohm's law experiment here, and for doing or for performing this Ohm's law experiment you have to study one circuit. Simple only. So already you know how to construct a circuit, how to connect the positives and negatives of ammeter, voltmeter, cell, isn't it? You know everything. So just we are going to draw a circuit. So study that also. Okay. Okay. So this is the electric circuit for Ohm's law. Now look here. The Ohm's law experiment is used to calculate the resistance of a given wire. That means if you are given a nichrome wire, you have to calculate the resistance. For calculating resistance, what all things we need? We need V and I, isn't it? That is potential difference and electric current we need. For measuring potential difference we need voltmeter, and for measuring electric current we need ammeter. How is ammeter connected in a circuit? In series. And voltmeter is connected in parallel. These are things you know. Now there should be a voltage source, or we call it as a battery, which will maintain the potential difference. So what all things we need? That is what I am saying. What are the materials required for this experiment? First one, you have to write the aim of experiment. What is the aim? To calculate the resistance. To calculate the resistance of the given wire. You will be given a piece of wire. The wire may be of 12 cm or 20 cm length. Then you have to connect these things. What all things you need for this experiment with the help of connecting wires. Okay, connecting wires we are connecting. When we go to lab you will understand. Now here the aim is to find the resistance of the wire. So this is the piece of wire here. This is the piece of wire. For example, it is a nichrome wire. Let us consider like that. Now we connected the voltmeter in parallel to that particular wire. Ammeter in series to that particular wire. Positive of ammeter is connected to positive of the battery. Negative, from negative we connected a switch. Now look here. What is this? This is the rheostat. Okay. Why you are using rheostat here? There is a sliding contact here. In rheostat, there is a thing like a rotatory something. We can move that. We can slide over a particular thing. Okay, by sliding only we are changing the electric current. That is the use of rheostat, to maintain or to regulate the flow of electric current in the circuit. Understand? So these are the things we require. So first of all, we write the materials required are, what are they? A resistance wire, then ammeter, then voltmeter, battery, then switch, rheostat, and connecting wires. Okay. Now you have to study this circuit properly, because in your board exams normally this circuit will be given to you not in the proper order. That means the positives and negatives will be shuffled and given to you, and you are asked to correct the circuit. So if you are knowing these things, what are the things? Very important from starting onwards I am saying, because negative of ammeter is connected to positive of voltmeter, positive of the cell is connected to positive of the battery. Then what? The current is flowing from positive of the cell to negative. These three things if you are taking now, it is very easy for the circuit to understand. Now these are the things required. What we are doing is, first we will switch on. We will connect the switch. Then the current starts to flow. Now by moving the rheostat, by adjusting the rheostat, you can see that there will be a deflection in the voltmeter, and when the voltmeter deflects, the ammeter also deflect. So there is a needle. In ammeter, there is a needle like this. This will start to move. And measurements are there. So we can note the measurement for ammeter, current as well as voltage, and we will draw one table like this. Then we will take V and I, and finally we will find V by I. So you will get V by I as a constant value. That is what we are finding, no? But due to some problems, means practically when we are doing, no, there will be some small changes because temperature may not be constant. So certain limitations are there. Then even though limitations are there, we can find it out. Okay, almost near to that we can find the value. Then V by I, we will get it as a constant, and when we draw the graph using V and I, you will get a straight line. So this will indicate that this resistance is a constant for this particular material, for particular length. For that particular length, resistance is there. Understand? So the details about on what all factors the resistance depends and such things we will discuss in the next class. So you have to study it thoroughly. Okay. Otherwise you will not get it, because we are looking into the continuation of resistance in the next class also. So study it properly, read the text, write it and study, draw the circuit diagram and study. So have a nice day, and thank you all.